Hello, it's good to have you here. I love to tutor. This question is on page 163 of Functional Mathematics for Senior Secondary Schools, Book 2 by T.M. Asiru et al. So the question says in figure 10.18, line PTQ is a tangent to a circle RST at T. Line SR is equal to line ST and angle RTQ is equal to 68 degrees. Find angle PTS. Okay, so we've been told to find angle PTS. It's this angle right here. Angle PTS, that's this angle between this chord ST and this tangent. Okay, so now looking at this tangent, two angles are found. There are two angles between this tangent and these two chords on this circle. Now you have two chords. You have two chords here. You have chord TR and you have chord TS. Okay, that are connected to this tangent. So now one of the theorems, the tangent theorem, is that the angle between the tangent, okay, to a circle and a chord through the point of a contact is equal to the angle in the alternate segment. Now we're going to take this gradually so we can fully understand. Now this tangent PTQS, between this tangent and this chord TR, this angle RTQ has been formed. Okay, so the theorem says that this angle here between this tangent, that is angle RTQ, that is angle RTQ is between this tangent and is equal to the angle in the alternate segment. Now just look at this circle, and just look at this chord TR. Okay, this chord is dividing this circle into two segments, into TR segment, this smaller segment from this point to this point, and then into another segment, another area that is bigger than this TR. This area is the smaller segment, and then the whole of this area is the bigger segment. So now you have that in this smaller segment between this chord TR and the tangent, 68 degrees have been formed. Now in the alternate segment, okay, in the alternate segment there's an angle here, so the theorem says, the tangent theorem says that the angle between the tangent to a circle and a chord, okay, this tangent and this chord through this point of contact is equal to the angle in the alternate segment. So the alternate segment is this segment, and the angle that has been formed here is TSR. So you have that TSR is equal to angle RTQ. Angle RTQ is equal to angle TSR. Okay, reason is what I just stated, so let's still write it. Angles in alternate segment. Okay, this is in relation to a tangent, to a chord, okay, and a tangent of a circle. So angles in alternate segments. So now, RTQ, we have that RTQ, angle RTQ already given is equal to 68 degrees. Okay, it was given to us, it was given. So you have by this that since our angle RTQ is equal to 68 degrees, therefore angle TSR is also equal to 68 degrees, and that is this. TSR is 68 degrees. Now, since TSR is equal to 68 degrees, okay, since we were told, we were given that line SR is equal to line ST. This was given. So, and therefore it implies that okay, it implies that triangle TSR is isosceles. It's isosceles. So, and if TSR is isosceles, then you have that angle STR, angle STR is equal to angle SRT. Now look at angle STR. This angle right here is angle STR. Okay, and then SRT is this angle right here. So they are equal because they are base angles of an isosceles triangle. Okay, so the reason they are equal is because they are base angles of an isosceles triangle. All right, so now since we have since we have gotten TSR, angle TSR to, okay, since we have gotten angle TSR to be 68 degrees, so it will be very easy for us to just get this. Okay, since these angles are equal, then we'll just subtract TSR from 180 degrees and then divide it between these angles. So now, since angle STR is equal to angle SRT, it implies okay, so anywhere I see angle STR, I can call it SRT and vice versa. So we have that okay, we have that angle TSR, okay, is equal to, sorry, angle TSR plus, let me erase this. Angle TSR plus angle SRT plus angle STR is equal to 180 degrees. Okay, sum of angles, okay, sum of angles in a triangle, So, and we already have that we got TSR to be 68 degrees. So we substitute it here, 68 degrees plus angle SRT. SRT SRT is equal to STR. So we can just say another SRT since they are the same. Okay, so equals to 180 degrees. So we now have two SRTs here. So we have two angle SRTs equals 68 degrees. 68 degrees plus two angle SRTs, and then we have 180 degrees. So now we have that okay, so let's collect like terms. We have that 2 of triangle SRT is equal to 180 degrees. This comes over to this side, so we have minus 68 degrees. Okay, so we have 2 angle SRT to be equal to 180 degrees minus 68 degrees will give us 2 degrees, so that our angle SRT is equal to 112 degrees divided by 2. So we have that angle SRT is equal to 5, okay, 56 degrees. So since we have here so here we have that STR is equal to SRT, and we have that SRT is 56 degrees. So it also implies that angle STR is also 56 degrees. So angle STR is also 56 degrees. Now let's go back to our diagram. So we impute this and see how it helps us to find angle PTS. So STR here is 56 degrees. So we have this to be 56 degrees, and this 56 degrees as well. 56 degrees. Now looking at this, okay, now looking at this tangent PTQ, looking at the tangent PTQ, now there's an angle between this tangent and this chord TS, okay, and that is this angle PTS that we're looking for now. And according to the theorem that we stated, that the angle between the tangent of a circle, okay, which is the tangent of a circle and a chord, okay, are equal. Now between this tangent and this chord TS, we have this angle, and this angle is supposed to be equal to another angle in the alternate segment. So this is a segment, and in the alternate segment is this segment, and in this alternate segment on this circumference we have this angle 56 degrees. So we have that PTS is equal to angle TRS. Reason is that they are angles in alternate segment. So angle SRT is equal to angle PTS. Okay, reason is that they are angles in alternate Sorry. Okay, so they are angles in alternate segments. Okay, so now, and we have SRT, we already have SRT as 56 degrees. So therefore, angle PTS is equal to 56 degrees. That's it.